Hello, this is Mr. Henry, and welcome to Lesson 2.5, Converse of the Pythagorean Theorem. The essential question says, how do I apply the converse of the Pythagorean Theorem to learn about triangles? The warm-up question says, you know now that a squared plus b squared equals c squared works for right triangles. Do you think you could determine if a triangle is acute, right, or obtuse also? So what the question's asking is, you know this works for right triangles. Would this also possibly work for acute triangles or obtuse triangles or something like that? And the answer is, well, sort of. The Pythagorean theorem here, we're going to see in this lesson, it can't solve missing length problems if you have an acute triangle. It can't do that. But what the Pythagorean theorem will allow you to do is maybe at least determine if something is a right triangle, and if it is, then you could use the Pythagorean theorem to find a missing side. So we've got three vocabulary words here. We've got Pythagorean theorem, which we should know at this point. A squared plus b squared is c squared, where a and b are the legs, c is the hypotenuse. An obtuse and an acute triangle are two, old vocabulary words. Obtuse triangle is a triangle where the largest angle is an obtuse angle, and an acute triangle is a triangle where the largest angle is an acute angle. And for those who don't remember obtuse, obtuse is bigger than 90, acute is less than 90, and obviously a right angle is equal to 90. So in this lesson, we're going to use the Pythagorean theorem to check to see if a triangle is acute, right, or obtuse. Then from there, later on, we might be able to use that knowledge and then solve a problem based off of it. But let's start at the beginning. Determine if each triangle is acute, right, or obtuse. The first problem says triangle ABC has side lengths 5 inches, 6 inches, and 6 inches. Okay, so the directions say determine if the triangle is right, acute, or obtuse. So, well, the Pythagorean theorem, the a squared plus b squared equals c squared, the longest side is always this c. So 6 is the longest side. So I'm going to put one of the 6's here. And then the other 6 and 5, I guess, just fit in here. So 5 squared plus, erase, 6 squared. And if I square everything, simplify, so I get 25 plus 36 equals 36. And this adds together to give me 61 equals 36. So first thing you should say is, no, that did not work out, Mr. Henry. That did not give me a right triangle, because if it was a right triangle, a squared plus b squared should equal c squared. These are not equal. So this is not a right triangle. So now we have to figure out, is it acute or obtuse? Well, here's an easy way that I think about it. Look at this hypotenuse. This hypotenuse of 36. That hypotenuse is too small. Because it's too small, it means that the angle, remember on a right triangle, across from the largest angle is the hypotenuse, so across from this right angle hypotenuse. Well, because this hypotenuse is too small, its angle is also too small. This is an acute triangle. And that's as simple as it is. Acute triangle. Letter B. XYZ has side lengths of 5, 12, and 13. Alright, so a squared plus b squared equals c squared. The longest side is the hypotenuse, or should be, so I put the longest side in for the c, so 13 squared. the 5 and the 12 just fit in here, so 5 squared plus 12 squared. 5 squared is 25, 12 squared is 144, 13 squared, I can double check, I believe that's 169. There you go. Simplify here, 25 plus 144 is 169 equals 169. And look at there. When we did this problem, we plugged the values in from the problem. We found that the two sides were equal, exactly like they should be if this was a right triangle. Well, guess what? This is a right triangle. This is one of those popular Pythagorean triples of the 5, 12, 13 that maybe you remember from previous lessons that we've talked about. That is a right triangle. This letter C, it says triangle LMN has side lengths 10, 8, and 6 meters. Determine if that triangle is right, acute, or obtuse. Go ahead and pause the video now. When you're ready to continue, hit play, and we'll go through it together. Okay, so let's see here. A squared plus B squared equals C squared. The longest side should be the hypotenuse. The other two sides just go in for A and B, so 6 squared plus 8 squared. That's 36. That's an ugly 36. That's 36. That is 64. That is 100. 36 and 64 is 100. That is 100, which means this is also a right triangle. It's a right triangle because this worked out. A squared plus B squared was equal to C squared. That's what the Pythagorean theorem says works for right triangles. You can say say LMN is a right triangle. Okay, so that's what this converse of the Pythagorean theorem really does for us. It's using the Pythagorean theorem in another way. Instead of using it to find the missing side of a triangle, we're using the Pythagorean theorem to determine if something is a right triangle. And that's all we're doing. Next problem, example D says triangle DEF with side DE equals 18, EF equals 12, and DF equals 4. Okay, is this triangle acute, right, or obtuse? And how could you change this triangle so it's a right triangle? So if you could, go ahead, pause the video, try this on your own. When you're ready to continue, hit play, and we'll go through it together. Alright, so first thing that I would do is I would draw myself a picture of this thing. Now, I'm going to start by assuming it's a right triangle. I don't know if it is. And so we had D, E, F. It says DE is 18, EF is 12, and DF is 4. So it looks like my picture is a little off. I can modify, easy. That should be the longest side. 12, 18, and E is over here. Alright. So I want to know, is this right, acute, or obtuse? So I'm going to use my Pythagorean theorem. Now, you didn't have to draw a picture, but I'm a huge fan. The longest side is your hypotenuse. 18 squared is here. The other two just fill in A and B. 4 squared plus 12 squared gives me 16 plus 144 equals no clue. Clear, clear. 18 squared is 324. Simplify, well, let's just add the 16 and the 144. Gives me 160. Yep. Alright, so based off this hypotenuse is too big. The longest side is too long. This is obtuse. So, is this right triangle right, acute, or obtuse? It's actually obtuse. And how could you change this triangle so it is a right triangle? If you didn't do this part yet, please, really, pause the video, try this part on your own. See if you can change it so it is a right triangle. If you did it already, let's go through. So there's actually a couple different changes you could make. You could change the 18, you could change the 12, or you could change the 4. All you'd have to do is use the Pythagorean Theorem, plug in two of the sides you want to keep, and put a variable for the side you don't want to keep. So in my problem, I don't want to keep this 18. So I'm going to make that an x. A squared plus b squared equals c squared. That is going to be my hypotenuse. Or I guess I could use the x. And then the 4 squared plus the 12 squared, that gives me 16, and 144 equals x squared. That gave me 160 equals x squared. If I square root both sides, I'm going to get like 12.8 or something. 12.64 equals x. That was from square rooting each side. So my three sides would be 4, 12, and 12.64. You could have also done the same problem, but instead of replacing the 18, you could have replaced the 12 with an x. Or replace the 4 with an x. All three of those would give you different triangles, but they all would have been correct ways to change this so it is a right triangle. One last thing I want to mention here, which it's kind of bugging me internally, but I'm going to leave it because I like to bring this point up here, is when I had 18 in here, this triangle is not even literally possible. This is not a triangle you could actually draw. Go, how on earth can you say that? Of course, there's your 18, 12, and 4. Well, when you have a triangle, think about it this way. If I would take this triangle and exchange it. Let me see if I can get myself a triangle here to represent what I'm talking about. Yeah, that might be the best one. No, it's not. Oh well. If I try to take a triangle and modify it, and imagine I start taking this top corner and I start dragging it down that direction. This triangle eventually becomes obtuse, and eventually it comes down to a point where it's almost a straight line. Well, what happens when it is a straight line? This side 4 and this side 12 would be like the base. So there's your 4 and your 12, and I know it's very ugly in these pictures. But together, that would be 16 if it's flat. This top side of 18 cannot be bigger than these other two sides put together. You can't have it. I mean, think about it. If you had this side was 12 and the other side was 18, there's your one side, and like there's your other side sticking way out here. That cannot exist. And I'm only bringing this up because it might come up sometime in the future that this is not an actual possible triangle you could have, because this side this is not even an actual triangle that could be drawn with 18, 12, and 4. Okay? It's beside the point of this lesson, but it's worth bringing up, and it's something interesting to think about, is that one side of a triangle cannot be bigger than the other two added together. Okay? Letter C. Or actually, next example. Next example here. Nice little application of the converse. It says a carpenter is framing out a doorway, and he wants to know if the door is a rectangle. The height of a doorway is 84 inches, and the width of the doorway is 35 inches. I need a picture. So the height is 84, I think it said, right? Yep, and the width is 35. So there's my door. He measures the diagonal distance of his door and finds it's 90 inches. Is this doorway in the shape of a rectangle? Okay, so let's start there. I mean, the second part, this is kind of a leading question. How long would the diagonal distance have to be to make sure the doorway is a rectangle, which makes you think, no, it's not a rectangle. It's not, but let's figure this out. And this trick actually does work if you're doing construction. This is something my father taught me way back when we were starting to make an addition onto our house. He measured this side, this diagonal, and used the Pythagorean Theorem to check to see if this is actually a right angle. A squared plus B squared equals C squared. And you've got your 90 goes here, your 84, your 35 squared plus equals, just filling in the stuff, substituting, plugging in the values from the picture into the problem. Mr. Calculator is going to come in handy. We've got 35 squared, 1225, 84 squared, 7056, 90 squared is going to be 8100. If I add these together, hopefully we get this. It doesn't look like that's going to be the case, though. I'm just looking at the last digit. 6 plus 5 does not give me a 0. It gives me a 1. 1225 plus 7056 equals 8281. So the hypotenuse is too small, which means this angle is too small. So this would be something less than 90. The doorway, now I'm going to exaggerate it, but the doorway would be like this, leaning. And you don't want a doorway that's leaning. You want your door to be a right angle, to be a rectangle. Alright, so this is not a rectangle, and there's proof. Pythagorean Theorem doesn't work. How long would the diagonal of the doorway, this diagonal distance, have to be to make sure the door is rectangle? So if we erase this 90, now say, okay, how big does that have to be? Pythagorean Theorem can help us there as well. A squared, B squared, C squared. I'm going to leave the C as C. That's my hypotenuse. That's my missing piece. We go back to the 35 plus the 84. It makes me wish I did not just erase everything I had up there. That's 1225 plus 7056. I love my brain. I can remember that stuff. And then the 1225 plus that was our 82 something. 81? Yeah. 8281. And then I'm going to square root each side. Ooh, I love it. Came out to a nice pretty number. C equals 91. So when I measured it in the problem, it was 90 inches. That was too small. The Pythagorean Theorem says it should be 91 inches. And another little trick for those construction workers out there, if you measure this diagonal and this diagonal, and they are the same, then your shape would be in a rectangle. If you'd like to figure out why later on, you may, but it is true. If your four sides are the same, the top and the bottom are the same length, the left and the right are the same length, and if your diagonals are the same, your shape is a rectangle. Now, letter B. The measurements of a triangular yard are 30 feet, 40 feet, and 50 feet. Is this yard in the shape of a right triangle? Go ahead and pause the video and try it right now. I think a picture is in order. There's our yard. Ooh, I love the green too. So we've got 30, 40, 50. I made sure the 50 is on the long side across from what I think might be the right angle. And I guess I could throw my labels in there. Feet, feet, and feet. To check if it is a right triangle, we have to use this Pythagorean theorem. And so I'll do our a squared plus b squared equals c squared. And actually, if you're not sure, you can make a little question mark above the equal sign. I don't know if it's equal. Interesting. And this would be, the long side is the hypotenuse, this 50. And over here we've got 40 plus 30. That will be 250 or 2500. That will be 1600 and 900. 2500 here, 2500 here, and the answer is yes, they are equal, which means yes, this is in the shape of a right triangle. It's only going to be a right triangle if the a squared plus b squared equals c squared, because that's what the Pythagorean theorem says. And the Pythagorean theorem only works for right triangles. If you're doing the problem and you find the hypotenuse, this c value, if the hypotenuse is too small, it's an acute triangle. If it's too big, it's an obtuse triangle. Letter C says, would an equilateral triangle be an acute, right, or obtuse? Why? Well, first off, if I have equilateral, the problem is not telling me how big each side is. So I kind of have my own decision. That's not perfect. I thought that was going to be a perfect equilateral. Well. I kind of have my own decision on how big I want each side to be. So pick a number. 5. 5, 5. Is this acute, right, or obtuse? Now, you may know this just from general knowledge, and your general knowledge hopefully says that this should be acute. It is acute. In fact, because all the sides are the same, all of the angles are the same, and 180 divided by 3 is 60. That's how big each angle is. And since the largest angle is acute, it's an acute triangle. Now that logic's wonderful and perfect and great, except I would like to use the converse here just so we have practice with it. So this converse Pythagorean theorem, and I'm just now realizing that this is spelled wrong. That should be a V. Is that wrong on the other pages too? Of course it is, because I just copy and paste from one page to another. Sweet. Oh well. So that converse of the Pythagorean theorem, I want to use that as well. So a squared plus b squared equals c squared. And that gives me 5 squared plus 5 squared equals 5 squared, and 25 plus 25 equals 25. 50 equals 25, and see, this thing that we thought was going to be the hypotenuse, the longest side, is too short. And because it's too short, it's an acute triangle, just like we said. So I've now given you two different proofs of why this is acute, using, well, kind of general knowledge, and using this converse of the Pythagorean theorem. Imagine that's a V. Application of the converse. So this is the last problem for this lesson. It says, draw 3 triangles and label the lengths of the sides. Triangle ABC must be acute. Triangle LMN must be right. Triangle RST must be obtuse. Use the converse of Pythagorean theorem to show that triangle ABC is acute, LMN is right, and RST is obtuse. And I say with a partner, if you have a partner. So, try this problem right now. You're going to draw yourself 3 triangles, and then prove that each of those triangles, that one is acute, one is right, and one is obtuse. Go ahead, pause the video, and do this problem right now. Alright, so I'm going to start with my right triangle. I'm going to pick one of the Pythagorean triples that I know. I like the 5, 12, 13. I know that's a right triangle because that's one of the Pythagorean triples that we've talked about. And so I can go ahead and do the converse here. A squared plus b squared equals c squared. And check it. That's the hypotenuse. The 5 and the 12 go in these other spots, giving me 25 plus 144 equals 169. This does equal 169. So yes, this is a right triangle. Now, all you'd have to do to take this same triangle and now make it either obtuse or acute is change the length of this hypotenuse. Make it too big or make it too small. So to make it obtuse, I'm going to make this hypotenuse too big. I'm just showing it's really hypotenuse. So 5, 12, and remember, you can't go bigger than this. You can't go bigger than 17, or else it's not an actual triangle. So maybe go with like 15. That should be too big. 13 is just right. This one's too big. Over here, 5, 12, and smaller, make it maybe like 10 or something. So it's kind of like the Goldilocks zone. This one's too small. This one's too big. This one is just right. A squared plus B squared equals C squared. I've got my 5 and my 12 and my 15. 5 squared is 25. 12 squared is 144. 15 is 225, my brain tells me. 225. 15 squared. Yep. And that gives me 169 and 225. Whoopsie, that's too big, just like we wanted it to be. So this guy is obtuse. And the first triangle over here, oopsie, A squared, B squared, C squared, 5 squared, 12 squared, 10 squared, is 25, and 144, and 100. Yeah, this is very exciting, right? I'm just kind of repeating the same thing over and over again. 169 equals 100, and would you look at that? The hypotenuse is too small, just like we wanted it to be. Because the hypotenuse is too small, this is an acute triangle. And I guess I didn't even do my labels. What's the first one is ABC. Whoa, what happened there? The first triangle is ABC, A, B, C, L, M, N, R, S, T. There we go. Make it all nice and proper, like labels and everything. So, that is how you tell if, that's how you use the converse of the Pythagorean theorem to determine if triangles are right, acute, or obtuse. Summary. In the summary box, what can you learn about triangles using the converse of the Pythagorean theorem? Go ahead, pause the video, do it right now. So I said, using the converse of the Pythagorean theorem, you can learn if triangles are right, obtuse, or acute. If the proposed hypotenuse is too small, it is acute. If it is too big, the triangle is obtuse, and if the hypotenuse is just right, the triangle is a right triangle. This has been lesson 2.5. Thank you for watching.